before you can recognize abnormal rhythms, before you can diagnose dangerous arrhythmias, and before you can confidently read an ECG, you must understand normal sinus rhythm. Normal sinus rhythm is not just another rhythm. It is the baseline, the reference point, and the gold standard against which every other cardiac rhythm is compared. If you truly understand normal sinus rhythm, interpreting ECGS becomes logical instead of overwhelming. So let's take our time and break it down carefully. Every normal heartbeat starts in a very specific place inside the heart, the sinoatrial node, often called the heart's natural pacemaker. This small cluster of specialized cells sits in the right atrium and has a unique ability. It can generate electrical impulses on its own, without needing any external signal. This automatic electrical activity is what keeps your heart beating, even while you sleep. Once the sinoatrial node fires, the electrical impulse spreads smoothly across both atria. This causes the atrial muscle to contract, pushing blood into the ventricles. On the ECG, this electrical activity appears as the P wave. And this brings us to one of the most important principles in ECG interpretation. If the rhythm is sinus, P waves must be present. No exceptions. Let me emphasize this again, because this concept cannot be overstated. P waves define sinus rhythm. Each P wave represents atrial depolarization, originating from the sinoatrial node. That means the impulse started where it's supposed to start. The atria are being activated normally, and the heart's electrical system is functioning in the correct sequence. In normal sinus rhythm, every QRS complex must have a P wave before it. P waves should be consistent in shape, and they should occur at regular intervals. If you don't see P waves, or if P waves are not consistently related to QRS complexes, then the rhythm is not sinus. After the electrical impulse travels through the atria, it reaches the atrioventricular node, or AV node. Think of the AV node as a gatekeeper. Instead of allowing the impulse to rush straight into the ventricles, the AV node slows it down, just for a fraction of a second. This delay is crucial. It allows the ventricles time to fill completely with blood before they contract. On the ECG, this delay is measured as the PR interval, the time from the start of the P wave to the beginning of the QRS complex. In normal sinus rhythm, the PR interval is constant, and it is less than 200 milliseconds. This consistency tells us that conduction from the atria to the ventricles is happening normally, beat after beat. Changes in the PR interval can reveal important pathology. If the PR interval is too short, it may indicate an accessory pathway, where electrical impulses bypass the AV node and reach the ventricles too quickly. If the PR interval is prolonged, this suggests AV block, where conduction through the AV node is delayed. But in normal sinus rhythm, the PR interval is steady, predictable, and within normal limits. Once the electrical impulse passes through the AV node, it rapidly travels through the His-Purkinje system and spreads across the ventricles. This phase is called ventricular depolarization, and it produces the QRS complex on the ECG. Because this conduction system is fast and efficient, the QRS complexes in normal sinus rhythm are narrow, sharp, and uniform in appearance. This narrow QRS tells us that ventricular activation is occurring through the normal conduction pathways. In normal sinus rhythm, the heart rate typically falls between 60 and 100 beats per minute. However, it's important to understand that sinus rhythm can exist outside this range. When the rate is below 60 beats per minute, but P waves are still present and conduction is normal, this is called sinus bradycardia. When the rate exceeds 100 beats per minute, yet the rhythm remains sinus in origin, this is called sinus tachycardia. So the key question is not just how fast the heart is beating, but where the rhythm is coming from. Let's look at what happens when the sinoatrial node is no longer in control. If P waves disappear and QRS complexes continue, the pacemaker has shifted elsewhere, often to the AV junction. This results in a junctional rhythm, where electrical impulses originate near or within the AV node instead of the sinoatrial node. Recognizing the absence of P waves is often your first clue that sinus rhythm has been lost. After the ventricles contract, they must reset electrically before the next heartbeat. This recovery phase is called ventricular repolarization, and it appears on the ECG as the T wave. The time from the start of the QRS complex to the end of the T wave is known as the QT interval. In normal sinus rhythm, the QT interval typically falls between 400 and 440 milliseconds, though it varies with heart rate. This interval is clinically important because abnormal QT durations can predispose patients to dangerous ventricular arrhythmias. So let's summarize what normal sinus rhythm looks like on an ECG. 1. A regular rhythm. 2. A heart rate usually between 60 and 100 beats per minute. 3. P waves present before every QRS complex. 4. A constant PR interval, less than 200 milliseconds. 5. Narrow QRS complexes. 6. And T waves, following each QRS complex representing ventricular repolarization. If all of these features are present, you are looking at a classic normal sinus rhythm. Understanding normal sinus rhythm allows you to quickly recognize abnormal rhythms, identify conduction abnormalities, and make faster, safer clinical decisions. Every arrhythmia you will ever study is, in some way, a deviation from this normal pattern. Master this, and everything else becomes easier. If you found this explanation helpful, make sure to like the video and leave a comment below. We read your feedback closely, and it directly influences future content. Don't forget to subscribe and turn on notifications so you never miss an upload. Thank you for watching, and see you in the next video.